Welcome to part 4 of my series on parametric differentiation. So you have got the two parametric equations of a curve, which is x equal to 1 plus 2 times sine square theta, and y equals to 4 tan theta. Show that dy dx is equal to 1 all over sine theta cos cube theta. Okay, that is part A, which we are going to do. And then part B, it requires us to find the equation of the tangent of the curve at a point where theta is pi over 4. And then you're supposed to give your answer in the form y equals mx plus c. And take note, they don't really say the exact values of m and c. So it most probably be the fact that we are dealing with a pi, we're going to have a decimal answers over there that you can also give, obviously. Right, so we're going to find dy dx. So we're going to use the chain rule, where the chain rules say that dy dx is going to be dy d theta times d theta dx. So if x is equal to 1 plus 2 sine square theta, then we have dx d theta, which we're going to change. So if you find obviously the derivative, maybe before I do find the derivative of theta, maybe just to write down what does this means here. This sine square theta is the same as sine theta times sine theta. Now, of course, I'm going to use the product rule whenever I do the derivative of that one there. Okay, of course, you can use something else altogether. So the product rule, so dx d theta will be the derivative of 1 is just going to be 0. Okay, then I have got 2 multiplied by the derivative of k of whatever you have got in here. So I can think of this as the first function. So say keep the first times the derivative of the second, which is cos theta, plus the second sine theta, times the derivative of the first, which is going to be cos theta. That's it. Okay. Now, if you have to clean up the bracket inside, then you're gonna have the 2 still outside, but you have 2 sine thetas here and 2 cos thetas. So at the end of the day, if you further have to multiply these out with the 2 that is in front, dx d theta is 4 sine theta cos theta. But we are looking for, this is dx d theta. We are looking for d theta dx. Okay? So therefore, d theta dx will just be 1 over all of that 4 sine theta, okay, cos theta. All right. So these take care of the theta dx. So we need to do the other one as well. So I'm going to bring the other equation down. Okay, here's y equals to 4 tan theta. So maybe I can just do it underneath here. So the other one is y equals to 4 tan theta. Okay, if I'm not mistaken. Well, the derivative of this one is very straightforward. dy d theta will be 4 sec square theta. There, we are done. Right? So we need to multiply the two of them together in order for us to find dy dx. So we have got that. Therefore, dy dx will be maybe if you just, always, I can perhaps clean this one further, just so that I don't work with that. I don't work with that sec there. I know that this is the same as 4 multiplied by 1 over cos square theta. It's always important that you do have a look at what you're supposed to get whenever you have got such questions. So this is dy d theta. And the reason I went further is because I could see something what this is supposed to give me. It's supposed to give me something with a cube, you can check it out. We're supposed to get something like this. So in order for me to get something like that, okay, that I can just grab also, or take a snapshot of. So this is what we are supposed to show, and you can already see that within there should be obviously some cosine that is cubed, right? So dy dx, from what I have, because I'm not done showing that, so dy dx is going to be 4 dy d theta, which is 4 all over cos square theta. I'm going to multiply that with, what was the other one? The other one was 1 over sine theta cos theta. 1 over 4 sine theta cos theta. 1 over 4 sine theta cos theta. So it's 1 over 4 sine theta cos theta. Okay, well, I'm realizing a couple of things here. The 4's, they cancel, okay, and then I'm going to have 1 over, if I multiply the numerator with the numerator, obviously it's going to have 1 all over, now cos sine theta times cos, and the cos squared times cos to the power 1 theta is cos cubed theta, which is what we initially were supposed to prove. That is dy dx over there, and it looks exactly like that. Right, now for the b part of the question, so perhaps I need to go and bring that b part of the question down because I don't have it. So the b part of the question says find the equation of the tangent of the curve. Okay, good. So it implies we need to find a point. So find the equation of the tangent of the curve. We just make sure that we have that over here. Okay, maybe I can again, as I said, include my pages, append a page. Maybe I'm going to append 2 pages. So we are supposed to find that. What is it else? What else do we need? So we know that at a point, so where if theta equals to pi over 4, we know that x was equal to 1 plus 2 sine square of going to be pi over 4. Okay, we're going to see what that gives us. And then we have got y was equal to 4 times the tangent of pi upon 4. Well, if you grab your calculator, obviously, you know, this is the same as 1 plus 2. Then you have sine. Just remember, this is a sine of pi over 4, that's squared. That's what that means, okay? That's what that implies. So you can definitely rewrite it like that in your calculator. My calculator is in radian mode, so that's 1 plus 2. In bracket, I've got sine pi over 4. That is pi over 4. Okay, close that, and that should be squared. Okay, that gives me a value of x, which is 2. So the value of x is 2. Okay, and if you were to do the value of tangent is just going to be 4 because tangent of 45 degrees is 1. 1 times 4 is 4. Okay, that you should know. Right. So what is our point then? So our point is then 2, 4. This is x sub 1 and that is y sub 1. What is it that we need to do? We need to find the derivative at theta equals to pi over 4. So dy dx, so when theta equals to pi over 4, dy dx is going to be, which was 1 over, remember, sine of pi over 4. Make sure that we write that correctly. Sine of pi over 4 times, I'm going to write cosine in brackets of pi over 4 all cubed, right? And see what is it that we're getting as a result. So we'll just grab a calculator so you don't make a mistake, okay? So that's going to be 1 all over sine of pi over 4, okay? And that should be multiplied by, in bracket, cosine pi over 4, and that should be cubed. I'm going to get 4 as an answer, so that gives me 4. Okay, so my gradient is 4. And if that is the case, I have my point, I have my gradient. I can actually now write my equation of the tangent, which is y minus y sub 1 is equal to m bracket x minus x sub 1. And they want it in the form, y equals mx plus c. They actually gave us that information. Okay, that's what they are saying, and that is what is there. Right, so it's just simple plugging and so on. So we know the point is 2, 4. Okay, so y is 4, so this is going to be y minus 4. Its gradient is 4, and then its x is minus. Well, our x value was again was 2. Our x value was 2, so bring down that 2. Okay, so bring down that 2. Right, so y minus 4 is equal to 4x minus 8. And then, of course, you just bring that other value back. So y is equal to 4x with minus 8 plus 4, eventually giving us a final answer of y equals 4x minus 4. Okay, I thought there would be some decimal values, but this is the solution. And we have our solution. Okay, that was part 4 of our series on parametric differentiation.